Hello everyone. Welcome to one of the one of the, one of webinar ITC webinar for the first one on the second semester of 2026. And today we have my colleague here, Dr. Ricardo Primi, that will talk about artificial intelligence and creativity assessment. We ran a survey for some weeks ago, and a lot of people asked us to do webinars about artificial intelligence, and for sure it's one of the hot topics in terms of assessment today. And here we are, one more webinar dedicated to artificial intelligence and the relation with assessment in general. So, welcome, Ricardo, again to our webinar. I will let you to introduce yourself, but first one, I'm very glad you came. You made to this webinar. Ricardo is a professor at University of San Francisco at the Graduate School of Psychological Assessment. Uh, his research, especially on artificial intelligence, psychometric intelligence, creativity, personality. So welcome again, Ricardo, and thank you so much for accepting this invitation.
Okay, so thank you, Philippe. Thank you for ITC to inviting me. I'm very glad to be here and share what we are doing on this like artificial intelligence. Um, can I share my screen already?
Yes,
Yeah.
sorry.
So okay. Okay. Uh, so let's start. So my topic today is AI-based automated scoring for creative thinking. So I will show you some studies that I have been doing. So as Felipe said, so I'm a psychologist, but working more on data science. Recent, like for a kind of 5 or 6 years, I started back studying artificial intelligence with all the developments on machine learning and all. And so I spent these years researching and applying, especially specifically in creativity testing and also in personality assessment, how we can use AI since like the RNNs, and then came like LLMs. And so I have been working with this since then, since like 2019, I think, exploring how can we do that. And I think we are approaching like now some results that can be real, can like foster real use cases for automated scoring. So I will show you. So let's start. The topics, I have these 7 topics. So what's creative? A little bit of creativity first, then the challenges of the assessment, and then I'll go to AI-based approaches, and then some projects that I'm working and results that I found until now. Okay. Let me start my chronometer here. So first about creativity. What is creativity? Okay, so just like basic concepts on the area. Um, Creativity is its ability to produce new ideas or original ideas, and is defined by 2 features: ideas that are novel, original, and also useful for like solving problems in real life scenarios and or in several domains, right? Um, Usually, we conceive two types of abilities. Like one is a creative potential, is this like capacity to generate novel ideas, to generate new ideas that are potentially useful, not necessarily, but they are potentially useful. And also, in the other side, creative achievement. That's actually products that are useful, recognized by society as valuable and novel, and have a real world impact. So we have these two kinds of concepts on creativity and also in assessment. We also split, like we are divide creative achievement in levels like Usually, when we think about creativity, we think about big C, like big theories, like Einstein's theory of relativity, and all these like big, eminent products, right? But the products can go from there to all the special, like mini C's, like creative ideas that you have in your own life. It's not like very eminent for society, but for you is new. So we have these different levels of creativity, like by Pro C is more professional products, right? And like novel theories in one area. Little C is like everyday solutions, like in everyday life. And mini C is more of like inside the head of a person, like novel interpretations that he come up with, and that's important for him or experience. So you have all these levels of creativity, right? Um, Especially here. So here's so it's the definition of achievement, like creative achievement. So we have all these levels. Um, Here's I have some ideas about the relationship of creativity and intelligence. There's this interesting book chapter from Sternberg and O'Hara. So they conceive all these ways the two constructs can be related. So it's more abstract representation. They can be disjoint or coincident or overlap in subset or superset. What is appears to be like with creativity and intelligence is that like creativity is kind of a superset, is more than intelligence, and intelligence is part a big part, but it's like a subset of all that is involved in creativity, right? It's kind of this intelligence is seen as a tool or subcomponent that's mobilized within like a broader, more comprehensive creative process. So, and what composes this creativity there? Then, if it's not like only part of intelligence, right? So we have this very nice paper from Benedek from 2024 that he has like a model. He combines and put all the like the important piece together, right? So so we have, as I said, creative potential and achievement, right? So we have all those concepts of little c and to pro C, and then here the potential for creativity, and like the potential creativity creates like illicit creative behavior, right? And then that will lead to production kind of products, and then this could be recognized as not as useful and could be like little c big C, or and then so you have this. But then in this level of potential, like the latent level, creativity is like is related to, of course, ability. We will see what kind of ability is behind creativity, but also specific knowledge, expertise in some area, and also personality, right? Some traits are related to creativity. Okay, so and then this engaging like creative behavior, and then this could lead to more like products of creativity. Uh, how about the intelligence? What processes are here? So I brought this kind of a more uh, comprehensive framework for intelligence based on CHC theory, Cattell, Horn, Carroll, right? And then we have this in the intelligence side, this difference, these concepts of conversion thinking. That is usually the test that we use in intelligence assessment, that I have like one correct response that you need to arrive to. So you need to think to arrive at some converge to one responses. And then we have this other process that's more like you start from one idea and diverge for different possibilities, right? And this is the main process within cognition that's related to creative potential. Here, so we have all the main like factors within CHC theory. Here's like the reasoning ability, GF, like the fluid intelligence capacity to relate, to create associations between ideas, right? The inductive and deductive processes, and this is connected to controlled attention and also working memory, right? So all these components are related to fluid intelligence. And then we have like long-term memory, right? Our knowledge. And this long-term memory can be divided by like content of this information, like general knowledge, mathematical knowledge, specialized knowledge in domain areas, language, and like procedural knowledge, eidetic knowledge. And but one of the abilities is just to use those knowledge, right? And this is more this is related to one ability that is our capacity to store information and then recover, right? And retrieve those information. And most of the cognitive tests measure that, like NAEP, SIAB is in Brazil, like that measure language, math. So they are measuring if we learned something, if we stored some like procedures, knowledge for math, and also for language, but also knowledge in some area. So usually the idea here is that you can access information and recover. But creativity is different. It's kind of another process of retrieval by association. So you activate one node and then you retrieve associated other knowledge related to that node. So it's not like assessing knowledge. It's like it is activating one knowledge and then assessing uh, associated other knowledge related to that point. And then the far from that point, it is this knowledge that you are retrieving, the more kind of potential to be original, right? Because you assess one knowledge, one distant knowledge, and we call this remote associations, right? But it's this idea. So you activate one, and by association, you recover. So this is the cognitive process that is related to creativity. Here I have like a very interesting old author that he creates this idea of bisociation. Arthur Koestler from this book, The Act of Creation, and he thinks that usually we think in one way, but the creativity is more related to dissociations when we connect two domains that are not usually related. It's this process of like activate one domain and then by association bring another domain together and bring those two domains that are not usually associated together, and he calls this bisociation process. It's interesting that he produced he kind of analyze this dissociation process in three ways. One is when we collide to domains that are not usually seen together, and when we put together, it's kind of strange, and they are colliding, and this generate tension, and this tension dissipates in humor, like in laugh. So he explained humor with this kind of process. And then we have like the aesthetics, that is like fusion, or just actually not fusion. It's just putting two things that are not usually together, but they kind of and lives together, but it's kind of give a new way of seeing one thing. It's more just it's putting one above the other. And then in scientific knowledge is kind of a fusion. You fuse two different areas in one new idea, right? Bringing information from the other side. And then there's like this idea of fusion, dissociation or fusion, also appears on Sternberg's theory, domain interaction theory. He has a very interesting theory. It's based on a work from Hummelhart. This is kind of an interesting story because Hummelhart is one of the fathers. He is on the papers from AI, actually, from backpropagation, actually, I think. And Hummelhart was the group with Jeff Hinton on the parallel distributed processing that came up with the like core ideas for training LLMs or neural networks. But he also Hummelhart has one paper on reasoning, and then Sternberg inspired on that to create this theory about metaphors. And what is his theory is about? So you have here two domains, like so you have C here, and you have concepts like boat and sea, and boat is a transport on the sea, and you have another domain here, for instance, desert, right? Another place. And when usually we can, I'm put this example to explain this metaphor. Like, for instance, the camel is the boat of the desert. So, right, so this makes sense. And why this makes sense? Because we have this domain, but we are using one a concept from another domain to explain something about like the camel here, like that the camel is a means of transportation here, using borrowing from another domain, right? And in order to like produce good metaphors, so you need to have parallel relationships within domain, right? And then, for instance, camel is transport, as boat is transport, like analogy between these two domains. These relationships needs to be kind of harmonious, connected, and creativity is related to this, but also to be related to the distance between these domains. And so these studies that Turanjo also did with Stemmer are really interesting. So they are measuring the distance between domains and showing that good metaphors have like a big distance and have these parallel relationships. So this is kind of a cognitive explanation of this associative process, right, on creativity. And they underline the creative potential, the cognitive part of creative potential. Also, personality is related. I will not go a lot on personality, but usually so you have two factors related: openness, especially on cognitive exploration, like this inclination to seek new ideas, beauty, and concepts, but also extraversion, like the behavior exploration, is more related to seeking stimulation, rewards in the environment. And both are related to dopaminergic drives, the motivation system in our brain, that are connected to this plasticity, to the general this tendency to search for new things, right? Search for new ways, new foods, new things, right? So both of these personality traits are connected to creativity, right? So we have more traits, but I will not like go over all of them, but I can share the slides later. And finally, so I'm going to all these pieces of creativity that is related to the concept, right? So finally, we have knowledge. That's just to say that creativity is multidimensional. It's not like, of course, we have this cognitive potential, these processes, but they work on the specific domains, right? There is this also, again, Benedek and Paul Sylvan Jog, they did this inventory for assessing creative activities, achievement, actually, creative achievement. So they try to survey products that people do, creative products. And then they come up with this several domains to assess, like literature, music, arts, sorry, um, uh, cuisine, sports, visual arts, here is like theater or scenic arts or engineering, right? So we have also, in order to be creative, so you need to understand one area and need to understand what is missing, and then within that area, you come up with like by this process of association, of combining things that are not usually combined, and then come up with new ideas. But the ideas will be always in one domain, right? And that's also one of the big challenges to assess creativity, is how to assess creativity in several domains. We usually will assess some of them, but not all. Like sports, for instance, it's very difficult. Okay, so now let's switch gears to the assessment of creativity, right? So you have here one link that you can search. You can see some tasks that assess creativity, very usual standard tasks, and there's lots of resources there. They're very interesting. And also, I want to focus on the PISA test for creativity. I will bring some data that we are working on PISA, and all these tests, they usually work trying to assess the creative potential, especially the cognitive tests, right? Here I brought one very standard example of creativity assessment, is called the alternate uses tasks. As I download this from the website I showed in the previous slide. So we ask subjects to come up with new possible uses for a brick. And we have here like several spaces, and the people think about this new use for a brick, like, oh, I can do like weight to hold paper behind it, or I don't know. So you can think a lot of use. Now we can construct houses, of course, but this is the usual purpose of bricks. Or but then you can come up with another creative idea. So this is one type of task. Going to PISA. So how PISA, what tasks PISA use to assess creativity? So in PISA, they came up. So we have this document really interesting, like the framework for PISA, and they assess in the cognitive side, the objective tests. They use this model, and with four abilities, and actually three abilities and four domains. So PISA assesses these four domains, like written expression, visual expression, problem solving, and social problem solving, and scientific problem solving, and these four domains. And also these three processes, like generate creative ideas. Like this item is like a book, and need to like write a brief paragraph or two, telling what is this book about. So you need to create kind of the main story of this book, right? And right here. So this is measuring generate creative ideas, right? Another task is like this one, that is an image, and then you need to create three titles for this image, and they need to be very different in the original. And this is measuring generate diverse ideas, right? This kind of item. And then so we have another type of item, and this one, this is a visual. Oh, by the way, this two, I think, is written expression, right? So this one and the previous. And now, so we have this is an image, and you have some tools, and you need to create an ad or a poster for a science fair, and you need to use this. And the idea is the life in the deep space, and you need to create like a poster for like advertising this science fair. And this is a visual, right? Visual expression, and the ability to generate creative ideas. Another one is this. So you have a river, and you have like frogs that are dying, and you need to understand, or they know already that's not pollution of the river, and you need to, the population of frogs are going down, and you need to come up with more hypotheses than just pollution, right? And having to give like two hypotheses. And here is kind of problem solving task. So we have a like constraints of scientific thinking, and so it's problem solving on scientific problems. And the ability here is generate diverse ideas. Here is hypothesis. I don't. So there's other types of items that they provide some ideas and need to improve. So that's the last skill here. Okay. So how these tasks were scored, right? So we have four main criteria to score these ideas. The main one is flexibility, right? That is how original, how different is this idea. So this is one criteria. Sorry. Oh, I explain originality, not flexibility. Flexibility is how different they are, right? How if you give like three two hypotheses, how different they are. So this is flexibility. But the main criteria I just explained is novelty, like originality, right? So how novel is this idea? So this is one of the criteria. But we have another one, like appropriateness is if the person complies with the task and they give some responses as was instructed, right? So you need to do this first check. And also you have another criteria that is the value, is how useful is this? How feasible is this idea, right? For instance, for the frog tasks, or so how useful, how kind of does this idea have some value and will potentially be has a use in society. So this is also a criteria. So what PISA did, PISA mainly used these three in blue, and they score 0, 1, 2. And for diverse ideas, 0 is not appropriate ideas. 1 is that they are appropriate but similar ideas, and then 2 is appropriate and different. And for tasks on creative ideas, 0 would be not appropriate, and then 1 is appropriate but conventional, and then 2 appropriate and original. So you see, they combined this criteria for this assessment. So it's a mixture of flexibility and originality depending on tasks and appropriateness. Okay, so just for the Brazilians that are seeing how we did on the test in Brazil. So here I have like two distributions of the scores, and then OECD came up with like the 6 levels of the tasks, and this is so this is originality in complex context. This is multiple and ideas, and this is originality on simple tasks like level 4. And then we have this. This is general score for all the samples, international sample, and here in Brazil, and we have like we had a lower score, as similar as in math, and so we are trying to study this and understand these results and analyze the test. But one thing that's interesting to see, so I have here from this analysis is a scatter of a sample, like a 2,000 random sample from, actually it's 2,000 from Brazil, and a 10,000 random sample of the international sample. So here in the y-axis, I have the creative test, like the score on this test, creativity test. And on the x-axis, I have the reasoning part of the math test. So it's more of crystallized intelligence in math, right? And you see the correlation is pretty high. So each point here is a person, and the red dots are females, and blue are males. So we see females does better, and we were trying to see the relationship between intelligence and creativity. Usually is more of a triangular relationship, but we didn't found here, and it's around 0.60, and this is usually too high for creativity potential tests and intelligence in the creativity research. So we achieve usually the maximum 0.5, and in PISA test is like 0.60, 0.70. It's very high. So maybe because it's like verbal tasks on have other. So this task, it is like assessing this potential to come up with new ideas, but it's very complex and require a lot of knowledge and a lot of motivation to do. And maybe it's also tapping other aspects of expressive writing or crystallized intelligence. And this is kind of his being under like researching. Researchers are discussing the results and like debating whether the task was assessing real like creativity as you usually assess in other tasks of creativity, but that's an interesting result too. So what's the challenges of measurement in this test? We need a lot of work to do, right? Because it's open-ended task, so we need raters, trained raters to assess. So this is a very expensive assessment, right? Another thing is like for international assessments like PISA, when we need to calibrate these assessments and to create like a common metric between different countries, for instance, or so we have a much more complex problem because now we have items and raters are part of the equation for the difficulty of the tasks, right? How can we equate this and produce equivalent metrics across countries? I think this was not intended with this test by OECD just because of the challenges of this. So they standardize within countries. So they are just measuring within country variability, but not comparing. I'm not sure exactly, but not doing like or advising to do comparisons across countries because of this difficulty of doing this. And also, and here, in order to do that, we need to show rater equivalence, not only item equivalence, but also rater. I will show some results. I'm trying to do exactly that, like doing like more psychometric methods on trying to study this. And also another concept is that originality is kind of a culturally relative, right? So uh, the rarity or the low frequency of some domain depends on your culture, right? Something that is rare in some, like, so we have this example of maple trees, right? Those, it's common in Canada, but not maybe in some country on the other side of the world. It will be rare, right? So, and then we have this challenge: how can we define originality if in different countries we have like a different cultures, different base knowledge, right? And that's also a challenge. Okay, so can AI help on this, right? Can we use AI as a rater, and then we solve the problem of the working load from raters? And so, in order to answer this, we need to answer these questions. Can AI functions like a human raters? So we can break down these questions in several others, right? Is there agreement between AI and human raters, right? So would expect that at least we will have agreement similar to between two humans, right? Two human raters. And we expect that AI needs to be at least good as two human raters average agreement. So this is one question. Another one is, mm, does AI generated scores correlated with external variables, right? Criterion validity, the same way as human scores correlated with external criteria. So they predict the same thing. They use information from this assessment, like the utility of the, like in the massive sense of validity, right? The utility of the scores, like the criterion validity. Are they the same? If we consider only like automated scoring based on AI and human raters. um, and also the main questions for international assessments like PISA is, does these scores, they function equivalently across countries, languages, and different groups? Like if originality, right, that is the base of the rubrics for scoring, are country specific, right? Uh, do the AI scores function exactly the same way? So they are getting the same kind of originality, rarity when they see the responses. We need to ask also these questions for the human raters. Are the human raters doing the same kind of judgment? Usually in the creativity community, they say no, there is no way to do that because originality is culture specific. But of course, this is a scientific question. We need to investigate that. Okay, so just some ideas how AI is being used to score this test. So we are using now generative AI. And what is this? So it's kind of a machine that produce, basically is a very simple machine. You put text in, and then you have a neural network with attention and fully connected networks, and then this machine predicts the next word that completes this sentence. But and that's it. And then what happens to producing big text or solve problems? Then you put the word a key, like here, like creativity's ability to produce new ideas, and then enter again. Then this machine will predict the next word, and then what is inside is like, so we have like a machine that learned the representations of language, and can take like 1 million words and understand all the relationships between these words, and then produce these new words to complete this text, completing the task that we are asking them to do. So this is kind of a new, the generative models, just like a brief introduction. And how is this being used in creativity assessment? So I just published a review this year, and reviewing all the work that's being done, and also reflecting how can those be applied in PISA. There's mainly three ways. One is using the semantic embeddings. What is this? It's like the vectors that are used inside those models to represent language. So they have like this vectors of numbers that represent each word, each sentence. And we can use this to, for instance, get like a piece of text, and then you get an embedding of like a vector of numbers that represent the semantics of that piece of text. And then we can compare to like two texts, we can compare their distance. And we can see if they are semantically similar or distant, right? And this, for instance, has been used in the task of automated use, alternated uses for bricks, for instance. So we get the embedding for bricks or similar concepts, and then the semantic embedding of the responses that the subject gave, and then we compare them, and usually original responses would be more semantically distant, right? Because they are original, they are different from the stimulus. And this measure correlates 0.70 with human raters of originality in this task. And this worked very well for this task. And another way to use this is fine tuning. Fine tuning is you get a model. Usually we do this with smaller models like BERT, or small language models, right? We get those, and we do like so the model comes with the understanding of language. What we do, we train a little bit more on specific tasks like pairs of responses and scores, and then we fine tune the model to produce the scores, right? This is another way. And finally, few shot prompting. This is like using these big models, these like state of the art models that we just present like let me go to the next slide. So what we do, we present the instructions, the rubrics and examples of scores, and then we give responses, and then ask the model to score. So this is the most all applications automated scoring is using few shot prompting. So we don't need to train, we just use the model as it is, and then we give examples, and then the model, given this input, the model can understand and connect like the examples, the rubrics, and then produce like the scores based on these instructions. And usually the correlations between this method and scores are 0.70, 0.80, okay? So how those things are applied in PISA. So now I will go to some data that I did. So I have like 11 minutes to go. And so I have like working in main 4 projects, right? One is just studying together with the OECD and studying the feasibility or doing this automated scoring on PISA with the data that OECD has. Another one is another project like lead by OECD is like we got some responses and we rescored the responses based on more analytic criteria like appropriateness, flexibility, originality, usefulness, separate, and also holistic scores. So we are doing this with a small set of responses. Like 10 countries are doing that. Brazil is there. And I have been working with Portugal on doing some analysis of this. I will show the results. And then we have here in Brazil, one assessment of the free recall. We are including some tests on large scale assessments, and I'm doing like automated scoring. And this only works if I have an automated scoring. So I did automated scoring of a metaphor test that I will show you, and then I will show some results on that. And finally, we create like a tool, like a open web platform with the open items from PISA, and using information from these 2 studies, and we use AI to score those items and make it available to teachers and students if they want to like get the open items of PISA and then do a kind of assessment. So we are just finishing this platform, and it will be available like into 1 month or 2. Okay, so let's see auto scoring project. So what I'm doing here, so I'm using the data from the second study, right? That's more 3,000 responses, and what I'm getting from those responses is what I'm doing is like getting the scores from 6 and 8 human raters, especially these are responses that are part of the anchor study from OECD to study inter-rater reliability. So I get these responses and the scores from 6 to 8 human raters, and from Brazil and Portugal. And what I did is I tried semantic embeddings and also few shots. Semantic embeddings works well for the automated alternate use task, but not for PISA. Why? Because PISA is there is a bias with number of words, especially in semantic embeddings. And so this works well when texts are composed of small number of words, and usually PISA has more words. And these work a little, but not as well as has been working on those traditional creativity tasks. So we are finishing one paper comparing these things and explaining why. But I move to the next method, that's few shot learning. And then for this, so we have the rubrics and then 90 examples for each of the scores 0, 1, and 2 for each item. And then I tested 4 LLMs like GPT-5.4, DeepSeek, Claude, and Gemini, like the most up to. So these were the best models when I did this analysis, right? There is better now, but so let's see what happened with this. So what I have here is like so I get every pair of human judges, right? That scored some response. Usually it's 200 response for a pair of judges, and then computed the quadratic weighted kappa that is usually used in this area. And usually we expect 0.70 or more for kind of operational, for like serious assessments, we expect 0.70. So the human agreement is above, most like above 0.6, right? Here we have a human AI agreement, and based on all these models and the human. And we have like almost similar, but a little bit lower, right? In moderate range, but here. And then we have AI comparing all the models. So you see is more consistent than human. And this is common finding in the literature, that these models, so if you get different models, they all do the same. They are not like very original across themselves, right? So but they in this case, for applying the rubric, they are more consistent among themselves. And so you see other data here that I will show that we always find the same story. But I try to if we consider the human raters a gold standard, so they are really correct. So this is all AI is doing good, but not in some cases not very good. Okay, but let's see if we maybe also the humans are not some. There are errors here in the human scores, right? It could be. So what I did is I selected the 600 kind of cases where there is a difference between human and AI. And then I recruited like my students, postgraduate students here in Brazil, and they reassessed it. They looked to the response and the two scores and decided who is right, the AI or human. And and here I have like the results. And so here is the divergence score. So this is the score consensus, like a consensus score, aggregated score, human score, and then GPT. And then I compare each GPT. And here, if it's positive divergence means that humans gave more score than GPT. And in this case, it's 80% of the responses in this, so they are divergent, right? But who is right? And he's 80% of the time actually were human errors, not so we can say the opposite, right? The AI were right in these divergent responses. And 67 in general, there is like 50% of the cases that the humans were wrong, and 42% of AI. So it's kind of, so if we bring this to the equation, maybe the agreement will increase, right, between humans and if we adjust that. Interesting enough, the only situation, where AI have more errors where when there's a small difference between divergence about less than 1 point between the two. And then what happens is that AI give more score. And that we saw that AI is usually a kind of more lenient than the usual human rater. Here is the table. So you have how many responses, cases we have, and then the errors here, but it's the same information. Okay, so how about this, the other project, this rescoring project? This is interesting because we rescored using all these analytical criteria and also a holistic criteria from 0 to 7. And then it's like a community of creativity researchers. And here is the coordinators of the Todd Lubert is coordinating this project. And here I'm presenting the data from our group from Brazil and Portugal. We have like a paper that's like under review about showing these results. And what our questions is what is the agreement between AI and human raters, and also if LLM can function as a anchor rater, like across the countries. Why? Because here, so we have groups of raters, 7 to 8 raters in each country, and we created a bib design where each responses were, we had like some responses scored by all raters within each countries, and the rest of responses we do use bib, and then each responses was scored by at least 2 raters, and then we combine in different ways. So we have like a linked design within countries, but we don't have between countries linking. So we don't have responses from Portugal being scored by Brazilian raters and vice versa. So we don't have a way of linking this. So what I did is I used LLMs to, for 4 items, the LLM, like GPT 5.1, scored all the responses from both countries. So the LLM was an anchor rater, right? And here is results of this, like all the judges from Brazil, from Portugal, and their connection here is like kappa and correlations. But then the main story here is that GPT works as similar as judges. For instance, in Brazil, 77 is most close to the raters. In Portugal, is a little bit like the raters are more consistent between very high, like 0.80, 0.9, and GPT is 0.7, is more like similar to Brazil. So there's kind of more consistency in Portugal. But usually the AI is doing well, like working similar as the human raters. Here is interesting, like I use IRT, especially the many facets Rush model, to model the difficulty of the items and raters. And here's the distribution of the scores that are controlled for both items and raters difficulty. And here's here's the holistic score, right? And here, so you have the raters distributed. So one interesting thing is that there's a big difference between the two types, the countries. Like usually the raters from Portugal, they are more demanding, kind of more demanding on their scoring rubric than the Brazilians. And the GPT is kind of in the middle, right? That's an interesting, exactly in the middle, like being similar to both, right? Here is the distribution of the scores given by GPT and human. And I brought this because there is a very different distributions. For instance, illustration titles, like that book that we need to, or that image, we need to 3 titles. It's kind of an easy item, right? And usually the scores are in 4 or 5, and both produce, like GPT and human produce the same distribution. But this other item, yeah, so I have like 45. I have more 5 minutes, okay, Felipe. So this item, like is a story about that book, like with number 2983. So you see, it's not like that easy, and a lot of students doesn't give like the actually in Brazil, actually, right? So you have a lot of zeros. In Portugal, not too much zeros, right? So responses were not appropriate for a lot of students. But you see, there are different distributions, and one very interesting thing is GPT mimics. So they give exactly the same distributions for different kinds of items, and that's, I think, encouraging. Another thing that's interesting, one reviewer asked us, how do you know if the LLMs are using the same criteria as human raters? Okay, so we just saw that there is a high agreement, but how can I know? right? That LLMs are using the same criteria. So in this data set, we have the analytic scores for each responses and also the holistic scores. What we did is that we get an average analytic scores for appropriate, flexibility, originality, and value. And what we did is correlated the holistic scores with those analytic scores. And we did that for the AI scores and for human scores and for each country. Interestingly enough, what we found, so the red is for the AI, and so they are kind of the same in each country. So you see here the red dots for within countries, they are the same. And they are kind of depending more on originality and value. But when we go to the human raters, we see that in Portugal, the emphasis is more originality and value, and flexibility is equal, and appropriateness. So the ratings, the ratings from Portugal judges are more reliant on originality, especially value. So we tested this, and there's a significant difference. What we found here, our argument here is that, well, LLM is doing like a more similar similar weighting of these features of the responses than humans. Actually, humans are doing it differently. And we have all this analysis on the paper, and that statistics is statistically significant, this difference among the human raters. So that speaks in favor of the LLMs as an anchor rater, because they are kind of more consistent, right? As I showed in the other slides, like between them, they are more consistent. And now we are seeing that across countries, they are the same. Of course, this is only the same language, right? It's Portuguese. How does this work in that several languages? We need to do yet this to see. Another interesting thing is that here I have the distributions of the scores. Now they are controlled for the rater effect. And an interesting result is that if I get the adjusted raw score, for instance, for one here, I have illustrate on Titans. That task that is the task that you need to create different types for illustration. And there is a difference between Brazil and Portugal. But if I don't control using the IRT model with AI as an anchor rater, there is no statistical difference between the countries. But if I control, I found the difference. So what is happening here is perhaps there is this difference, but because the Portuguese raters are more demanding, and if I don't control this difference between raters, they will appear on the scores, and then the unadjusted scores are equal, but they are not. They are biased, right? Because we are not dealing with this difference between raters. And when I use AI and then have this anchor design and then use IRT, then I have like a controlled scores, then I see this difference, right? So this shows is not good for Brazil, this difference like in the, right, in the, but it's showing the results that we are finding, right? We have like a lower score in this test. And if we don't control this, the results will be biased. And then AI is being part of this control, right? Okay, so this is a general, like the final results on the equated scores. And then, so, and then we have here the reliability, the conditional reliability, considering all the sources, and is almost for the tasks above 0.7. That's really good. And then, of course, so we have the number of ratings we have for each responses on the country. So the reliability is high. And this is the whole model that use all the raters, AI as anchor, and comparing countries. So I have another validity data in a small data set, but I don't think I will have time. So I'll go directly to the conclusions. So yeah. And this is the platform that we are working on, and this will be available in 1 month, so you have use. What is the conclusions? So The LLMs achieved acceptable levels of reliability compared to human scoring, right? The challenging is still within how these models can recognize highly creative, like Pro C, Big C levels. Can they do that? If we see research that try to see if they are by themselves creative, they found they are kind of in line of this consistency. They are not as creative as humans when you ask them to produce creative response. But if you ask them to apply a rubric to recognize creative responses, they are good. They're doing a very well job, I think. And still, we need to do like very, very original, different ideas. Maybe they are kind of outside of the learning universe of LLMs. Are they able to recognize? We don't know yet. And it's difficult to study because those responses are by themselves rare, right? But I think for operational purpose now, I think LLMs can do the job, like to score a response, at least as well as humans. And so we have this question. We started to look into that, like if the rubrics they use or the like the features the LLMs are looking to the responses are similar to the features that humans are looking. What we found here is that humans don't see the same thing, right? Comparing different countries, but LLMs see they usually weight the same features to score those responses. So also good results for using LLMs. And then but of course, if we have difference, this will bring like systematic biases that we need to control. But what we found here is more like the bias in human raters more than in LLMs, at least in this study. But we need to do this in more extended data sets with several languages to see what happens, right? Yeah, so I think that's the main topics that I had. I think let's we have like a few minutes for questions, Philippe. Sorry for to take a long time, but anyway, I will stop my. Okay.
Yeah. Thank you, Ricardo, for your presentation. It's for sure it's very enlightening, and you is one of the rare persons that can combine a very deep knowledge in a specific topic of creativity and methodological approach, especially psychometric and artificial intelligence. So thank you so much again for accepting this invitation for this webinar. And this is your presentation is very important for us.
Okay,
We
thank you
have
so much.
some, yeah, thank you so much. We do have some questions that we took from our pre-registration form, and
Mhm.
I'll go through these questions in a few moments. But I do have one my question on my own that
Yeah.
I'd like to give to you. You mentioned a paper that you published this year about different approaches of doing artificial intelligence, and I remember to discuss with you like 10 years ago of using artificial intelligence for different purpose. And artificial intelligence itself has evolved so much for the last 10 years. And back in 10 years, people are more prone to use like fine tuning, using the best model that they can get and using fine tuning. And now probably people are more used to get just those big commercial models like GPT,
Mhm.
cloud, and so forth. And I would like to hear about you. How is the performance of this model for creativity assessment? People just abandon fine tuning. They are still doing fine tuning, or they are more using more like those big models with few shots or uh,
Mhm.
something like this. And this is at the present, and what do you think will be the future of the
Okay.
using artificial intelligence on creativity assessment?
Yeah. Okay. No, great question. That's interesting also. Yeah. So that's some factors here, right? One of this using selecting one of the two methods, right, is the size of the model, right? The size, and size matters a lot, right? The size is like the size of the parameters of the model and also the training. And the training is divided in several parts. The pre-training, also now the agentic training or the reasoning. That is the post-training that they do with reasoning in these new models. So the new models are very, very big and trained in different modalities like reasoning, and that compose a big more power within the model. And then what we see usually in the so this is one factor, right? The size of the model. And fine-tune models you do with smaller models, like compare, for instance, BERT is like 200 300 million parameters, and then Fable now, or they say 25 trillion parameters, right? So it's much bigger, much more knowledge, so it's not comparable. So what happens is, of course, these new models are better always, right? And then another factor is the complexity of the task, and usually creativity is complex, right? So it's like writing and with this like different ideas, so it's highly complex task. Like we can also think about critical thinking or logical writing essays or something. So all this complexity needs like more complex models are to score, right? And so what happens is that in creativity research, what we saw is usually they're switching more for these few shots with bigger models, state of the art models, and those works better than fine tuning, right? I myself did on metaphor tasks, so I fine tuned BERT and also use GPT, and it's much better like the few shot, and because of this the size of the model, and BERT is not like very achieve like zero point 0.5 correlation, not, and compare like 0.70 with this few shot. So few shot works better. But of course, depends if a simple task. A lot of companies now are doing like they have kind of BERT or some GPT, small language models. They fine tune with a big data set and works better for them. Fine tune models, but the tasks are more simple, not as complex as this one. So, and what will be the future? As probably if we can find ways to fine tune bigger models, maybe this could be better. But the tendency is to use these bigger models, and they will kind of dominate. They are already dominating all the applications,
Yeah, yeah,
right?
yeah, yeah, yeah. People that are following artificial intelligence updatings, they also
Uh-huh.
know the same evolution in different areas. People are more using those huge models, commercial models.
Uh-huh.
Okay. Yeah, we have some questions from the audience, and I have space for two questions. One is Andrea. I can put on the
Uh-huh.
screen here. Is Andrea is asking uh,
Yeah,
in one of the charts, the kappa were greater for AI than human. So how do you
exactly.
conclude that AI is more consistent than a human?
Yeah, so that's an interesting, very interesting question, and I think this result is also found in these other studies that are using LLMs to score more objective crystallized tests, right? What they found is that the model. So one explanation I have is that, so first, yes, that's the result. They are more consistent between. So this is a comparison between, for instance, Claude, Gemini, OpenAI, and they are much more consistent than two humans, right? And assessing the same response. Why? Because they are kind of trained to do right things. They are trained to follow rules and do, for instance, for text, they are trained to write good text, right? In the pre-training. Pre-training is like internet data. And then they have like the instruct training for these models where they present text with high quality, like question answers, and with high quality and responses that solve problems and are correct English. They are English. They are correct, not with errors. And then so they become more kind of more used to apply correct rules in the same way, right? That's one explanation I have. And that's an interesting thing. That's it's difficult for the models. There is one research line to produce simulations, like to ask the model to simulate responses for different levels of ability. It's very difficult to get models to simulate responses with wrong response, like human error, by like our chaotic mind. They can't do that because they're trained in good examples, and they are more better to give you like very well polished responses than wrong and confusing responses, right? And then I think part of the more consistent responses is this. But also this could be also a limitation. So they can't like do very create a very high level creativity, maybe, right? At least now, because they don't have this kind of more chaotic mind like we are, like humans are.
Yeah. Yeah, thanks for your answer.
Yeah.
And the last question came from the our pre-registration form. Uh, this question is about like people are concerned, also concerned about the
Mhm.
how the data is trained and how bias is embedded into the LLMs, because they
Mhm.
can carry bias from the language, from the culture that the data came from. So the
Mhm.
question approached on this topic, and the question is, how can be sure that artificial intelligence based scoring are assessing the creativity rather than detecting linguistic sophistication, cultural convention, or patterns present in the training data?
Yeah. Yeah, no, so that's a really good question. I think this is understudied, right? This, and there might be different methods we can do. I can just tell you about. I think it's stressing what we did, right, in this and this rescoring project that's connected to ACD, because there we asked the human raters to assess those like analytical score, like how original is this response, how appropriate it is independently, right? How flexible are different are those ideas and how valuable are they? And then with human raters, so we have those scores, and then we compared we asked the LLM to do our holistic scores. Also, human raters had these holistic scores, and then we compared the LLM to this to correlated the scores from LLM to those human assessing this creativity analytical scores. So this if we did, if the humans, if we can trust these humans, right, these raters, as we usually do in our creative research, right, we trust them. So they are applying this idea, they are seeing these responses and assessing not linguistic sophistication, or they are applying more if it's original or not, according to their internal knowledge of the culture and everything. And what we found is that the LLMs have a high correlation with this, similar to both two raters in the same responses. So LLMs comes similar to human. So in this data set, we can say, oh, it's not kind of linguistic, especially this rescoring, because we had this project started because there is this question about PISA data, right? How much of these PISA scores are more of a linguistic scoring, right? When they did, than creative, more of this creative specific uh, uh, features that creativity studies. So we did the study. The study started just because of that. So we have all those scores. If we trust those, I think the results show that LLMs are kind of seeing more of going to this direction and assessing, as we ask it, originality, right? And we also have the rubrics that we explain. And I did also some, like I got some very weird responses I had from my subjects in metaphor tests, and asked LLMs to explain. And they get it. They get it. Even strange human chaotic responses, LLMs can understand and explain those. So I think, yeah, they are powerful to do that. And but of course, this is under study. We need more data. So we did that only in 2 languages, right? So what happens if we do in the 10 languages we have data set? Maybe that will be, yeah. Let's see what will happen. But I
Yeah,
have
yeah, yeah.
so far, I think it is doing a good job in assessing
Yes,
creativity.
nice. Yeah, for sure. Cultural bias are hot topics on artificial intelligence as well, and we
Yeah,
can see that as one of the topics that is under studying, and there'll be more studies on the next years as well. So
yeah,
again, thank you so much for accepting this invitation, Ricardo. It's a very pleasure to have you here. It's a very outstanding and very updated presentation, and also welcome appreciate the participation for everybody that was on this YouTube channel this afternoon. And also, please check our website, the International Test Commission website. Go to another videos that we have on YouTube. We also post something on LinkedIn as well. Please follow the all things that ITC has been produced. So thank you so much again, and see you in the next webinar in a few weeks, on next month. Thank you so
thank you,
much.
Felipe. Thank you all. Also,
Yeah,
thank you very much for attending, and thank you, Felipe and ITC, for this wonderful invitation. Thank you very much. Very proud, very uh, delighted to give this talk. Okay, bye bye.
yeah. Bye.